Test. 1, 2, 1, 2, 3. Great.
You gonna bop around a lot?
Oh yeah.
I'm going wide.
Yeah, go wide. It's bopping around is one of my things. Hi, 3 people. Good job. 4, 5. Great. Hey, Chris, are we live?
Right now, yeah, there's like a...
Okay, that's fine. If we're live, though, great. Hello, everyone. And hello, people in internet land. Couple interesting things. I mean, it's been an interesting day, I think. One, both Full Stack and Grace Hopper are part of this live review, and then also lecture that is going to follow this. If you are in the remote audience listening to the live stream, I've mentioned that, well, first of all, you click the right link because you're hearing this. And then 2, you can message Mithun. Mithun, are you here? Mithun, yes. You're going to have to yell from back there. That's okay. I can hear you. If you have a question and you are remote, you can message Mithun on Slack. He's only on the Full Stack Academy Slack organization, but for the Grace Hopper students listening at home, you should be part of that organization and you can message Mithun. Once again, I don't know where to look when I say these things because it's not to any of you. The other thing about this afternoon is that because of so many people being at home because of the weather, we have on the calendar a start time for the workshop, for the Redux workshop at 6 o'clock, but I don't want to send out pairs and get people working on it when there's so many people at home. So what I'm going to do is I'm just going to go to 6:30. I'm going to review and lecture till 6:30. All right? We're doing a review and a lecture, so it's actually 2 separate things. But I am just going to go to the end of the day and go later than the calendar, which, to be honest, I've done for way worse reasons in the past anyway, so it doesn't really matter. I don't know if I have to justify this at all. Anybody got any questions about that? And remote, if you have questions about that, you message Mithun. Cool. Huh? I'm always excited. Okay. Forms in this workshop. As is the case with a lot of live reviews, but especially for this Juke stuff, the Juke workshops are sort of built on purpose to be a lot of content, maybe often too much to get through in the allotted workshop time. I think a lot of our workshops follow that pattern anyway. But the Juke workshops definitely, so that they can be good review material to do in the future when you have time, like during review week or whatever, to just get some more extra stuff done. So what that means for live review is I would have to basically ignore your questions and any other kind of tangents that would help you learn in order to get through all of it. So here's a guarantee that I will not reach the end of this workshop in this live review. It's just not going to happen. There is a solution that I will share that will be at the end of this workshop and we'll reach the end, but we probably won't get to do that out loud. But also, at the same time, the idea is that everything that you were meant to learn and all the new concepts that come with React Forms will be addressed with what we do go through. okay? Even though it might not address the later challenges in the workshop. So the first thing we have to do, the first step of the workshop, other than a bunch of stuff you have to read and concepts, is we are going to work on this artists page. So the idea right now is this artist page just shows all the artists. And we are going to be using our first instance of an input in order for us to type in some characters and filter these artists down to what fits that typing. So it's not actually a form that we're using here. We're not talking about form interaction with React. It's really just an input. We're just talking about one input. It doesn't even have to be wrapped in a form. Just there's an input on the page. How do we listen to it and use its value to do other operations, in this case, filter an array? The way that this is set up right now is we have, in index.js, we have this artists route, which then renders out the artist component. There's no parameter here. There's no dynamic portion that we have to work off of. It's just show all the artists, and it renders out that component. And that component looks like this. It's a dumb component. It is a presentational component. And it just receives props and uses props.artists and then maps through those to create these divs with links inside, right? So the idea here is rather than our route tree rendering artists directly, we want to render out something intermediary. We want to add an extra layer between this route tree and, well, really the route tree and the app container and our artists component. And this is going to be the filterable artist component. So I'm going to go ahead and create that first. So I'm going to call this filterable artists container. Now, a container is essentially another word for what? Smart component, yeah. So presentational component or dumb component. That's when we define it as a function and it just takes props and the entire function is essentially render. But a smart component or a container is when we define it as a class and it can have a constructor and it can have an internal state and it has a separately defined render function. That's what a smart or smart component or container component is. So this is one of those. We're going to say export default class, and we can put the name of the class here if we'd like to, but not necessary if we're just exporting out the value. We do, however, have to import React and component, although we could just say React and do React.component. That would be fine. But we need it for extensions, so we do this. We could also do this, as you're starting to get used to. So we have a render method here, and I have, I believe, a bit to copy and paste here. No, not yet. That's for the filter input. But the idea is that this render will, for now I'm just going to return a div, but this render will render out artists and a new component that I'd have to build, filter input. And it will listen to the filter input, which will be presentational, but will essentially receive a prop function that it will call when its input changes. It will come back up to this layer in this filterable artist container, and then take the props artist that it's receiving and filter it down to pass down into artists. Because that's the idea here. The idea that artists is a dumb component makes it flexible for us to put layers on top of it. Really all this does is it takes an array, which is attached to the props under the key artists, and then maps over it. So if something limits that array beforehand, it's not really relevant to this component. This component just receives the input and then visualizes. So rather than going directly to it, which we are now, we're going to put a layer in between. And that's this component here. So we'll say this is a div, wrap this in parentheses, if I can hit that key. Right. And then this is going to render out artists, so we're going to have to import that. We're going to say import artists from, and then we're going to have to go up because we're in containers, down into the components, and then into artists. This file structure, by the way, is totally arbitrary. Like, you don't have to put your containers and your components, your dumb and smart in specific areas, or even name the files in any given way. It's all purely convention for organization, but it's arbitrary. But it makes sense. And then we're going to do this filter input thing, which I'm just going to import ahead of time, even though I have not created it. But I'm going to say filter input from components, filter input. And let's build that file real quick. Filter input.js. So here I got a little bit to copy and paste, so you don't have to see me write this out. This is directly from the workshop. So filter input, as it stands right now, it is a form with an input inside, which isn't necessary. We don't actually have to put this input in a form. It could just be the input itself, which I am going to do, even though it'll mess up the styling a little bit. I'm just going to do that for the time being so you can see that this works without it being wrapped in a form. But this is just going to be an input that its responsibility is to receive a function through its props. So let's say that it's going to receive like a, what should we call this? We should call this like props handle input, or when changed, or on change, whatever you want to call this. It's up to you. But we're going to say that when this input changes on change, we are going to invoke props handle change. And this handle change is not attached to the filter input component itself. It's being passed into it by its upper layer, by what is rendering filter input. So if we go back to where that is happening, we can say, filter input, what should you do when your input changes, when somebody types into you? Well, I'm going to say handle change, I believe is what I called it. This dot props, or just props handle change, yep. I'm going to pass down a function. So I'm just going to, for now, let's just do console log. That's a function that I can pass down. OK? Just passing down console log. All right. Cool. So let's see what this does. But first, we need to actually use this component instead of our artist component. So we're going to go to the route tree, and we are going to replace artists and its usage right here in this route with this filterable artist container. So we're going to say filterable artists container from, and then containers, filterable artist container. I'm just going to close this file here. And then we're just going to put that there. OK? So we've replaced direct usage of artists with this container that we've built, which is going to, in turn, render artists. Right now, I haven't provided props, but also the filter input on top of it. So let's go ahead and see what effect this has. So property map of undefined, yeah. I'm just going to get rid of this for now because we're not passing artists down. Bam Bam is thirsty.
Yeah, I'm not drinking that one anymore.
Yeah. That's his water now. For those who are remote, Bam Bam is drinking John's water. OK. So first of all, you can see that this styling is a little off, and that's because I unwrapped it from that form. But we can actually listen and hear these changes, right? All I'm doing is console logging, so what we're receiving here is the event object. But this is being listened to even though it's not in a form. So that's something I do want to get across, is that you do not have to put your inputs in forms in order to use onChange. Inputs can just live on their own. I like to think of inputs as being like the drivers for receiving these values, but forms as a way to compose them together and sort of group them. But it's the inputs that have this functionality on their own. But I'm going to put this now back into, I'm going to have to undo and redo a little bit because I don't quite remember what the other attributes on this form was. So now the styling should be the same, but then let's just do onChange again, because I can't redo, and then props handle change. OK? Cool. It should look a little bit better, at least be spaced out. All right. What are your questions about that? Does anybody have any bits of curiosity before we figure out, now that we're going to receive this value, what to do with it? Cool. I need all the time I need, so that's fine. Great. So, yes, great. Bethune.
How do we decide which components to make dumb and which smart? Can filter input the stateful and filter the artist array and then pass it to artists?
Yeah, that's a great question. So the question was, when do we decide whether to make components smart versus when to make them dumb? Couldn't we make the filter input component, which is dumb right now, that only receives props, couldn't we make it stateful, a smart component, and have it filter the artists themselves? Well, there's a couple things. One, I would say that it's always a priority for you to make as many of your components as dumb as possible. The reason for that is if you make your components dumb, one, they're more predictable because they don't hold any internal state, which means that it doesn't change over time. It always is just like input, output. And we're going to be talking about functional purity with Redux in the next lecture. The other thing is that this is more reusable now. Even though this has a placeholder of like enter artist name, we can just imagine that this is now an input that could work for anything. We can just toss filter input into a random bit of JSX, and it will be sort of isolated and work on its own. We would just give it handle change, and it would call that function. If we were to make this stateful, if we were to make this smart, and give it the responsibility of filtering artists down based on what it's been given, then that would mean that is always its responsibility. It's always going to be specifically this thing filters artists down. Maybe in this case with Juke, that's totally fine. But by making it smart, by making it have that responsibility, we've essentially limited it in flexibility. And I would say that just once we get like through the practices of using Redux and then following that React Redux, you're going to notice that almost all of your components are going to end up being dumb. You'll maybe have like a couple smart components, and that's it. And that's a good thing. That's a good thing because this is a lot easier to predict. Okay, I receive props, which are like arguments to a function, and it spits out visualization, as opposed to, I mean, this is an extreme example, but the app container. The app container, which can change in state in X many ways, Y many times, right? It can just like sort of like mutate how it's supposed to visualize over time. And then to a less extreme example, once we get through this is going to be based on different effects happening to it and it mutating, as opposed to pass props in, visualize, that's it. So yeah, try to make your components as dumb as possible when you can. But when you need a component to maintain internal state, like we do here, you should be using a smart component. So that internal state, first of all, let's make sure that we are receiving this correctly. This is going to be important. Now that we've made this intermediary level between artists and the app container, it means that we need to make sure that this layer now, this filterable artist container, is still receiving the artist the way that artist was, the data for artists. Let's just make sure that that's the case. So it starts off as an empty object, but then on the next render, which is triggered by app container calling setState after the AJAX call, we end up getting artist information. And we can just pass this into artists like we have been. We can just say, OK, artist component, here is your argument for what the artists are. It comes from my props like this. And it'll display out. But now the idea is that we want the filter input, when it has this change event happen to it inside, it calls the handle change that's being passed down, which right now is a console log, but I'm going to now rip it out. I'm going to say that this is going to be input changed. And it's going to receive a change event. And I'm going to say this input changed, right? And we can go ahead and activate on the value that comes from the input that it happened on, right? Which, by the way, this input that this change event happened on, do we see it in this file? Is it even part of this component? No. It is a full layer down, and it's this thing right here. It's not even filter input. It's like this input. So this is a reason why the event is used to go and get the element that this event happened to. Because sometimes when you handle that event, it is many layers upwards, and you don't actually have any direct reference to that input where we're at right here. And we don't, because that input is part of a second rendered out layer below it. So that's why the event is helpful to get the value. So now if we type this, we'll see the value getting console logged out, right? And what do we want to do with that value? What is the purpose of getting this value? What are we doing with it? Chris? We're going to, okay, so that's one thing we're going to want to do with the values. We want to put it on the state. But for what means? Like, what's the end goal of this value? We want to filter down the artist array, right? We want to take this .props.artist and filter it down. So I think it makes sense, yes, to put this on the state. We could also just like put the artists on the state that we received as props and then filter it down and then set state artist to be something new. We could do that, but it makes maybe a little bit more sense like this. And maybe we'll try both and sort of weigh the pros and cons. But we're going to do it the way that the workshop directed you to do it first. We're going to say that there's an input value that's going to be stored, which comes from the filter input, and it's going to stay as an empty string. And of course, if we're using this constructor, we have to provide super. That's what Webpack was telling me down here, by the way. This is not allowed before super. Oh, it went down again. Down here it says this is not allowed before super. And then we have this input value starting as this, and then we're going to need to use context in that input changed. So we're going to just set that up real quick, because this is going to do a set state. And now what we're going to do is we're going to say, when input changed, which is triggered by the on change in the input as part of filter input, we are going to say this set state input value is now whatever the value of that input is, right? And that's just going to happen on change, like as we are changing that. So let's just console log this dot state in the render and see what that looks like as we type. So the first two renders, it's empty string. The first render comes from it just appearing, the whole start of this. But then there's an AJAX request to the server that resolves in the app container, which calls setState, which triggers that second render. But now, if we type here, it's another render. There's another setState being called through our input changed function. So once again, something I mentioned in the lecture for both cohorts here, but every time you call setState, the component you call setState on is going to re-render. It's going to call its render function. And anything that is being rendered in that render function called, like going all the way down the layers, starting at where you called setState. So it's just something to keep in mind. It seems like a pretty apparent thing, but it anchors a lot of predictability when you start to get more and more complex. Renders are triggered by set states. Okay, so we have this going on. So we have the whatever I type in here attached to the state, right? So now what I want to do is I want to start using that state and that information from the state to limit my artist array. So I can either do this in line right here, or I could provide another function, but I'm just going to say filtered artists. And this is just going to be this.props.artists, and I'm going to use array prototype filter for this. And what I'm going to say is I'm going to say that for every artist, and you know what, it might actually make this a little bit easier and more elegant if I were to, before filtering, map it, because I'm going to need the objects. Never mind. We're going to say artists, and this is going to be the artist object, so artist object. And we're going to make sure that the artist object name, now we can use an ES6 feature here. This is an ES6 string prototype method that you may not have seen before. I know the workshop uses regex match, but this is another ES6 feature. There's three, well, there's a bunch of new string prototype methods, but there's three that are sort of relevant to this. There is starts with. So you can say this string starts with, a little bit of inflection here because it's like a question. Does this string start with test? And if it does, you'll get true. You can also do ends with test, and you'll get true if it ends with those 4 characters. Or you can do my favorite that I use a lot, includes. And what we're saying is, does this artist name include this .state.input value, what has been typed into that box? Now, there are some issues here, which we'll talk about in a second, but does that make sense? Stephanie, you had a question? I'm sorry, repeat? It's not. It's not. In this case, we're talking about a string, so it's a totally different data type, but the idea is that the interfacing of it is the same. And in this case, it's always expecting a string rather than like, if you were to give it an object, it'll toString the object. Or if you give it a number, it'll toString the number. Whereas with the includes with the array, you give it a number, it's going to look for that number. You get an object, it's going to look for that object, etc.
Is there a way to make a case insensitive?
Yeah, so that's the issue. That's the issue right now. So let's just see if this works, right? So we have our filtered artists, and we are going to say, instead of using this.props.artist, which this component's receiving, I'm going to instead pass down the limited artist that I figured out through this process. So now I can type in Creed, and Creed shows up. And I can type in J, and Jets Overhead, whoever they are, shows up. Right? And if I say EED, Creed is also there. So this works. This works. And it does it as I'm typing, which is nice. The problem is if I do this, so I have an artist named Tom York. I don't know if you've heard that guy. If I type in Tom with a lowercase t, this breaks because the string checking that I'm doing is case insensitive, which sort of sucks, right? If I did this, it would work fine, but you know, right? So is there a way to make this case insensitive? No, with regex we can. With regex we can. That's one thing that's nice about regex. But in this case, we just don't have really a way to do it. So what we could do is just to lowercase the name, and then see if it includes the input value to lowercase. It's a little bit more verbose, but that works. OK, so now I can type in Tom with lowercase t, or Radiohead with lowercase r, and it'll still work. Cool. So let's track the layers here. Let's track the layers. We have our index.js route tree, which through app container, because it is the root of this route tree, it will render out, if the URL is /artist, the filterable artist container. The filterable artist container then renders out this. It's going to receive this .props.artist through the children stuff that we've done in the artist container, or I'm sorry, the app container. And then we're going to filter it down based on the input value, which is, to begin with, empty string, which means that it'll show all the artists, and then this filter input is also rendered and passed a function that doesn't come from app container, but comes from this, right? And then as we're typing into that filter input, we're activating this onChange. It calls the function that's been passed in as a prop as handleChange, which then sets the state of input value on the filterable artist container to be some new value, which then we set state, it triggers re-render. It triggers render again. So we go back into render, but this time, this.state that input value is something different. So we go ahead and try to filter down and then re-render artist and filter input based on that. Does that make sense? I would say that this is like the basics of working with an input and how you sort of like signal up and then sort of like circle back down when it comes to those inputs. So in this case, container smart component that can have internal state renders a dumb component which handles the change, signals it up through a function, and then that smart component adjusts its state to pass data back down. So we're sort of like working internally. We don't have to go all the way up to the app container if we don't need to. In this case, we don't. What are your questions about this? Because I'm going to move on to playlist. OK, I'm going to take that as a good thing. Or maybe I should just stand here for a minute and make one of you ask a question. Thank you. Yes? Regex is one of those things that I have a hard time memorizing the syntax for. So I'm just going to defer to the workshop here, because I think the workshop gives you a hint that uses match. Yeah. But I will pull that up and see what it looks like. Artist filter, guide, and then somewhere in the solution we have.
It's just the same as includes, but match. Just say dot match.
Oh, I see. But there isn't any kind of like case insensitive thing that it's doing?
You do have to do the 2 lowercase if you want to.
Oh, interesting. OK. Yeah. So it's just using match. The thing to realize about match So we can just say, I mean, it's really just doing this, right? But the thing to realize about match is when you do this, you're really saying, in this case, new regexp, but let's just imagine that we just said like Radiohead. Whatever you pass into match as a string is going to get converted into a regex expression. That's the same thing with search as well, string search. And it probably includes as well, to be honest. But I think JavaScript sort of natively runs all of its string checking methods through regex. But if you do actually write in the regex like this, so in a way that's actually real here, we would have to do like new regex p, and then say this.state. And what we could do is we can say, this is like this stuff always fails to be remembered by my brain because it's regex and it's crazy. They call regex a read-only or a write-only language. Have you ever heard that before? Does that make sense? Like, do you understand what that means? It means that you can write it and it totally makes sense while you're writing it, and then you go back and read it and it makes no sense. So it's write-only. But I believe that this would work. So the G means that it'll find it anywhere in the string as opposed to like at the beginning or whatever. And then the I means case insensitive. Yeah. So I think that this would work, but nah. So it kind of screws up when you have an empty string. So we have to say if, I don't know. This is getting really tangential just to like figure this out. But yeah, you would do something around this line. So if we do Tom, I probably just did this wrong. But yeah.
That's fine. I got it sorted. I was just wondering.
Yeah, for sure. Regex is just one of those things that is like very powerful when you do have to write it and you get good at it, which I never have. But a lot of the times, for most cases, if you're not doing like some like crazy parsing stuff, you don't really need it. You're just looking for a sequence of letters and another sequence of letters, and that's pretty simple to do. Yeah, yeah. And there's lots of cool things out there. If you are interested in regex, look up regex golf. It's pretty cool. It's like go ahead and like eliminate all of these, but keep all of these in the least amount of regex characters as possible. It's pretty cool. Just Google that. Cool. All right. Any other questions about, yes, Mithun?
Yeah,
A couple. Great.
Filterable artist container, we didn't explicitly provide props to the constructor. Is that optional?
Is your mic on? Because I assume that it is. OK. Chris will figure that out. What's the question again?
In filterable artist container, we didn't explicitly provide props to the constructor. Is it optional?
Oh, I see. So in any smart container, what is the purpose of providing props through the constructor? Sometimes you want to base your initial state on those props. Like, for example, during the lecture, when I was doing that credit card form, some of those props eventually became what was the initial state for the form, so that we can see like if we were doing an edit form or something like that. So that's why you receive props here. And some people will also like call super with props. I think that was a sort of like necessary thing about React in an earlier version that people sort of internalized and made a pattern, but it's not something you have to do. The reason you receive props here is to, if you'd like to, operate on those props during your constructor. The most common example is for you to use the props as part of your initial state. So if we want to say like props start filter or empty string, we could do this, where like this filterable input. So this is a bit strange because it's part of our route tree. It's a little harder to provide props because we're not creating this. Yeah, this is. I would like for that to be an easier example, but we'd have to rip out a couple things to do that. But the idea is we could use filterable artist container with a start filter prop, and rather than it starting as an empty string, we could have it start with like Radiohead or something like that, some kind of state that is defined by how it's used. Bethune, you said that there was more questions.
Yes. Where or when do you want to use force update instead of just resetting the state or updating the state?
When would you want to use force update as opposed to?
Just resetting the state to render. I think first just means just giving a set state somewhere.
I see. Force update is something that I have never used. I'm assuming that this is a React method of some sort. Like there's a this.force update.
Yeah.
And what does that do, Bethune?
I think it just forces the component to re-render.
Oh, okay. So it's like just make it re-render, although state hasn't changed. Okay. I've built a lot of apps with React, and I don't even know about that method. So I don't know how to speak to when it's useful, because maybe it has been useful and I just didn't know about it. But I can't imagine why you would want to re-render if nothing has changed.
I feel like when I've read about it, it's usually kind of frowned upon.
Yeah.
And you should only, I mean, I guess it's kind of like a hack when something isn't working and you want to force.
What I can say about that as just sort of general wisdom is that a lot of these frameworks, one thing that's great about them is that they give you an organized way to structure applications. Something that's bad about frameworks in general is that they give you a generalized way to structure applications, meaning that you can't really go outside of that structure when you want to sometimes. So things like this, like force update, where it's like, go ahead and re-render even though state hasn't changed, which is supposed to be what triggers a render. That's probably something that somebody came up with some kind of like very esoteric issue where they needed this kind of thing, and they're like, hey, React developers, can you just put this in? I just need to re-render, but I can't change my state. And they probably like, fine, okay. Or it's something that like they need internally to do certain things. Maybe it's like part of the re-rendering process internally through React, but I don't know. I'm not sure what exactly the use case of force update is. But that's a great question. I'm going to go ahead and read about force update and see how people use it. OK, I'm going to move on because there's lots more to do. So playlists. Now that we've seen the usage of an input and its setting state, and it's sort of like wrapping around these layers a little bit, let's go ahead and do that again, but with something a little bit bigger. So we're going to be working on this playlist feature, right? This playlist feature. So the first thing we have to do is I think we have to update our sidebar. I apologize for not having this sidebar stuff, but I do now. And we're just going to go over to the sidebar real quick. This is one of the, this is one of the reasons why components are nice. Where is sidebar? How do I go and find the HTML for sidebar? Is it all in one big HTML file? No, it's in sidebar.js. So if I need to update it, I just go and find it, which is nice, right? So now I've updated sidebar. I can do that. Just these little things we take for granted, like the fact that that didn't work. It's probably because of this. I'm just going to say 2 and then empty string. That's fine. OK. So now we have this sidebar, and we've added a little bit to it. And we knew exactly where to do that, and that's great. And now what we want to do is we want to produce a new view. We want to produce a new view that's going to allow for us to create another thing that the back end is already ready to use and do, but our front end hasn't really been introduced to, and that is playlists. That is storing in the database a list of songs. And I just want to point that out to you real quick as well, is that there is like a whole like back end to this workshop that is just there for you if you want to go and look at, but you don't really work with. And that is this playlist thing, right? So we're storing playlists as rows in the database. And then there's a playlist song table, which is a belongs to many relationship between songs and playlists that say this song should be on this playlist, and vice versa. Right, so this actually has like express and SQLized foundations to where this data is being stored. If at some point you want to go look at that back end, you can, because there's a whole bunch of like patterns you probably haven't seen, sort of scattered and peppered around there, because we weren't writing that back end to be taught. We were writing that back end to work. So we sort of like do some more random, sometimes more complex things in our code that we don't try to show you as often because they can be really confusing. OK, so now I'm going to build this new playlist component. And once again, I'm just going to copy and paste, because who the hell wants to see me write JSX? And it's just going to look better if I copy and paste it as opposed to anything else. So new playlist component. This is just going to be a dumb component that's just going to render out this view for me to create a new playlist. So here we have const new playlist. It looks like this. We have a whole bunch of stuff, but this is not interactable in any way right now. And then we are going to export default this function. which is going to be, our component, our dumb component. And then finally, we want to say we're going to create a smart component called new playlist container, which is going to manage internal state as our new playlist is having information entered into it, right? This is going to be the bridge between our app container, which is going to have the functionality for how do we add a new playlist by contacting the backend, that AJAX call. And this dumb component new playlist that isn't actually doing any operations other than listening for input. So we're going to say export default class extends components. I'm just going to go ahead and copy and paste from this other file, this line. I'll copy this line too. Shablamo. And we're going to say bring in new playlists. And we're going to say extends component. And we're going to render. We'll probably also want to set up initial state. So let's just put a constructor here with a super and a this.state equals empty object just for the time being, just to prepare for that to be the case. And then inside of here, we say div. And we render out, in this case, I should probably change this variable, new playlist. We render out new playlist. So this is the layer in between. You sort of get used to this with React, where it's like I have a dumb component that visualizes in a important way. But I have a smart component living just above it that renders it out, that is meant to do some internal state management to send it up to the things that will operate, right? So my dumb component, which is supposed to just render something out, doesn't have to maintain state or be uber complex. This is also preparing us to understand React Redux a little bit more, in which a lot of these smart components that are really just wrapping around dumb components in very thin ways are replaced completely by a library. And we don't have to do this manually every time. But if you're not working with Redux or React Redux, then we still would have to do it. OK, so the new playlist. Let's add this to our route tree so we can actually start to look at this. So we're just going to go over here. I'll put it underneath the artist stuff. I'm going to say route. Path is going to be /playlist or new playlist. And the component that gets rendered out from this path is going to be the new playlist container, which I have to import in. New playlist container. New playlist container. Great. Yes, James.
Would you prefer we use hyphenated instead of camel case now?
In the URLs?
Yeah. So how are we supposed to do it?
As opposed to what? I'm sorry?
Camel case.
Camel case. It doesn't matter. I would say that there are some places in your code where convention does matter as far as what represents a space. If you're working with JavaScript variables, camel case. If you're working with HTML, IDs and classes, and any other attributes you might set, hyphens. If you're working with database columns, underscores. If you're working with classes, if you're naming classes like filterable artist container, you can see right here, capital letters, which is sometimes known as Studley case, which I like. I like to mention that. By the way, the hyphens through it is called kebab case, which is very cute. Although I always wondered, why is there not a hyphen at the beginning and the end? Because that'd be a really hard kebab to eat if I didn't have But anyway, the point is that there are conventions for different places. You can put your HTML classes as camel case, and you can put your JavaScript variables as having underscores between. The point is having the conventions in the different places makes you more aware of where information came from in the first place. If you're working with a property that has underscores as its spaces, you probably know that that lines up with the database column. If you are working with a value or a string value that you write in your code that has a hyphen in between, you have a general expectation sometimes that that's probably mentioning a class or ID in HTML. So you get these sort of expectations and predictability through doing that, through those conventions. But really, it's arbitrary. And then the URLs, I actually don't know. I don't know. I've always used hyphens, but it could be camel case too, I suppose. Daniel?
For search, Google, it's a more readable URL. The words would be separated. It's easy for it to
So are you saying that Google uses hyphens? Oh, interesting. So this is like a Google SEO thing? Oh, interesting. So Google SEO, which is a very, very important thing, determines that putting hyphens in your URL is a little bit more optimal than other things because of the way that it indexes sites and parses stuff. Interesting. That's very interesting. Did not know that. Cool. Very cool. All right, where were we? Yes, route tree. Here we go. We put new playlist container in that route tree. After importing it in, we should be able to see this new playlist now. And the other thing in our sidebar, which we neglected to do until now, is we need to put, as part of this link, go to new playlist, which should allow us to navigate there other than us putting it in our URL bar. So we go and do that, and of course something is broken, but I know what that means. React is not defined. Let's see what file it's in. New playlist line 3. I just didn't import React. Even though this file doesn't use React, right? If I go over to this new playlist.js file and I look all over it, let me just Command F. There's no instance of React being used here. Why is it yelling that it needs React? This is a question I've probably asked like 5 times to you, so you should know the answer. Because we're using JSX, and after JSX gets transpiled, it looks like react.createElement. This is not what actually executes in our browser. This is pre-Webpack, pre-transpilation, pre-Babel in this case. Once it has been translated to something that will execute, it's react.createElement. So we need to make sure that React is in this scope because we're using JSX. Okay, something to keep in mind. There's a Babel preset that makes it so that any file that has React in it will automatically import React at the top of it, so you just don't have to remember to do this over and over, but it's really not that big of a deal, I don't think. And I have some experience with that preset, and it gets a little wonky sometimes. But there you go. Now we have our view, right? Now we have our view, which is just rendering out this dumb component called newplaylist.js, and we're not interacting with it in any way. So let's start doing that. We are going to update the new playlist component right here, and we're going to say this. So a couple people asked me throughout the workshop why this part of their workshop wasn't working. They got the filterable artist thing to work, but there was something wrong here. And I noticed that a lot of people put the on change on the form, and that was their problem. In fact, I think somebody slacked me with why doesn't this work? And I didn't get a chance to answer them. I forget who it was. But this was your problem. I saw your problem, but then I got distracted by a help ticket or something like that. So if you know who you are, who I'm talking about, that's your problem. Oh, it was somebody remote. It was Omer. Omer, this is your problem. You don't put the on change on the form. You don't put the on change on the form. Because the form isn't the one updating values. It's the inputs inside. The form just allows for us to know when that form has been submitted. It does a couple extra things through composition of the inputs inside. But the input is where this value changes. It's the input. It's very important to remember. Especially since if you do this on change and you put it here, it's going to do a very unfortunate but reasonable thing in that it's not going to give you any error. You're going to put a function here. That function is just never going to get called. So you're not going to, it's not like a visible or audible bug. It's just OK, on change is not going to do anything on a form. And it's going to take you a while to figure out what did I do wrong. It's just one of those things that it's reasonable that it doesn't give you an error. React source code would essentially have to say, if they put on change on a form, let's throw a specific error about that. So it's sort of nasty. It's sort of nasty. But that happens sometimes. There are some times when those things just don't work out. For example, Rob, are you here? Rob? No. Rob was telling me a problem he had yesterday with this route tree. He accidentally did this. Instead of writing component, he wrote component. And the thing is, this was wrong, and this made it so that his artist view never showed up. Were you his pair? Who was Rob's pair yesterday? You went through this, yeah. Yeah. This doesn't throw an error. And when you hit the route, it'll just say, I have nothing to render out, but it doesn't say it to you. You just mislabeled something. but there's no error for it, which is really frustrating. So there's nothing really you can do about that except get good at your editor and get good at auto-completing and try to make these typos as infrequently as possible. But I will say that silent errors suck, right? Silent errors, the inaudible errors, they suck. And sometimes it's your fault because you forgot to do a dot catch or you forgot to do whatever you need to do to catch an error. So this is the kind of situation you'll find yourself in that is 100% your fault if you just don't do dot catches. So always remember to catch your errors, even if it's for something you think is going to work no matter what. Okay? Cool. Tangential lesson. Let's go back to what we were doing. Now we're seeing this new playlist form. So let's listen for it. We're going to new playlist. This is where we're at. We were going to put an on change here. So the idea is that, like our filter input, we are going to receive props into this DOM component. And this props is going to include a playlist like handle change. Sometimes it's hard to just like label these things, but this is essentially what it is: handle change. Handle change to the name input. And what we're going to do is, in this playlist container, let's just create a new playlist name, or playlist name changed. This is going to receive the change event, as we are getting used to. Change event from the input in the new playlist. And we're just going to console log change event dot target dot value. And we are going to pass this as handle change into our DOM component for new playlist, right? So it's the same stuff that we've done. Same stuff that we've done. So now we go here and we type and we see it console logged out, right? Because we've defined a function here, we pass it in as handle change. New playlist receives a prop called handle change, makes it part of that input change, on change, right? Same stuff. So now what we want to do is, when this does actually change, let's bind this ahead of time. Rather than you getting the opportunity to tell me, don't we have to bind here? No, y'all are great. I didn't mean to sound sarcastic or anything. It's just, OK, so possible playlist name, right? It might be the name of a new playlist or new playlist name, whatever you want to call this. Like, you can make this as specific to the data itself, or you can just call it input value, which is extremely vague. But like, it's up to you. This new playlist container, this is meant to create new playlists. So you can be, I think, a little bit more specific about what this is. And then we can say new playlist name comes from, and then in this case, change target value, change event target value. And we do that. And now, one thing that I like to do when I'm doing set states and testing them is I like to render out the state, or console log the state object in the render function, because I know that set state's going to call a render, so I can see as it changes, right? So I go ahead and do that, and indeed it is changing my state effectively. So the new playlist container is essentially a component that is holding onto some internal state for us to eventually send somewhere. So the other thing that our new playlist has to do is it has to tell us when there is submission, when we click create playlist, right? That's going to be another prop. We're going to say this form on submit will call props handle submit, right? And then we'll go over here and, right here, and we won't put a different function for this yet, but we're just going to say handle submit. So we're, as I've mentioned before, I always think about using a component as invoking a function. Each prop is an argument to that function, like a named argument. So we're passing in, and we're going to just say, console log submitted, right? We're just passing this function in. So now we go here, and we say that, and, well, we got the refresh bug. We got that refresh bug, which, by the way, happened to some people and didn't happen to others. And I haven't really gotten to the bottom of this. I'm not sure what it's about. But let's move this out, and we'll say handle submission here. This will be our submit event. Our submit event will do its prevent defaults, and then we can console log submitted. And let's just say this handle submission. Oops. Handle submission. And once again, as I mentioned in lecture, take this opportunity to practice some keyboard shortcuts. Duplicate. Select. And then if your autocomplete doesn't work, you should probably figure that out as well. But you can just do that. It's an annoying, tedious thing. Make the best out of it. Like, make the most out of you having to do this over and over. Practice those shortcuts. OK, so now this should work a little bit differently. If we just spam this button, we get submitted, right? We can type this in, and we say submitted, submitted. So the other thing that probably should happen here is we need to start working with the state, right? So we're going to say this.state. So when we click submit, we are not just going to console log submitted. We're going to use the state to do something, right? But before we go past this, before we go upwards to the app container, to what this should actually do, let's talk a bit about validation. We have very, very little to validate here, and it's pretty contrived, but it is, all validation is essentially contrived. It's supposed to set standards. And the validation we're going to use here is that the playlist name that we want to name a playlist after shouldn't be nothing, and it shouldn't be longer than 16 characters. So how do we set that up? And by the way, the effect of our validation is not going to be us showing any kind of message or anything, which was probably what we should do eventually, but it's really just going to be the inclusion of this disabled property on our button. So by putting disabled property equals true, or disabled property equals anything, on this button, we are essentially saying that this button, which happens without condition right now, just can't be clicked. You can see that my mouse has like this little stop sign over it. It's just like this form can't be submitted. Even if I do this and press enter, the disabled button will make it so that it can't be submitted. This is not submitting the form. So that's happening unconditionally right now, which is not what we want. But what we do want is maybe passing the current playlist name down to the new playlist and reading and operating on whether it's valid or not. So we can say, do this. Let's pass the current value down, and that's going to come from this.state. What did I call this? New playlist name. New playlist name. So that's going to get passed down as current value for new playlist. And what we're going to say is valid. We're either going to say if it's valid, or let's do not valid, because it's a little bit easier to understand the conditional if we do it this way. We're going to say props current value is not equal, or is equal to an empty string. That would not be valid. Or props current value length is greater than 16. Right? So those were the two conditions in which it would be invalid. And now what we can do is we can say disabled is equal to, we could just do not valid. Booleans get confusing, but if we say it's not valid, disabled should be true. So therefore we say disabled is equal to whatever the Boolean represents for not valid. So I believe that this will work. So when it's empty, you can see that this is disabled. But then we type in something, and it lights up. And then if we keep typing, it eventually goes dark, right? So it's disabled if we do this. It's disabled if we do this. But if it's a little bit, we can submit, and we can also press enter, right? But if it's like that, we can't press enter. That make sense? Cool. What are your questions? I'm getting good at that. Oh, yes.
So in your example code, you always have prevent default as the first thing. In
Yeah.
React docs, I always have it as the last thing. Does that matter?
It does not matter. It does not matter. I would imagine, I'm not sure if React's, the people who wrote the documentation, which I'm assuming are the core maintainers, have a reason for putting it last, other than I think maybe putting it last makes it less important. Sort of like, when journalists write articles, they put the most important things first, and then they get to the least important things last. So maybe putting it at the top is just sort of like, yeah, of course this is going to happen, but it distracts away from the real logic. So maybe that's why it goes last. I've just gotten used to putting it first because that's just like the pattern I've been using since writing in jQuery. It doesn't matter where it goes. Yeah, it doesn't matter where it goes. Because the full submit handler is going to be executed before any default functionality runs, like making the request in this case.
Joe, someone asked that you just repeat questions that people.
I'm sorry. Yes, I'm sorry. The question that I just explained was the React documentation puts prevent default at the bottom of event handler functions as opposed to the top. And is there any reason why you would do that, putting prevent default at the top or bottom? And in this case, no. There is no reason why you would put it at the top or bottom other than it being less important code to read. That's it. That's it. What my explanation was before is my explanation. So this would be exactly the same. We'll put it at the bottom just to prove that this works. OK, great. So now we are submitting. We get a this.state. We are doing this. So where does this need to go? Now that the new playlist container is wrapping around this DOM component, producing and packaging this information, knowing that it's valid, what we're going to do is we are going to pass this up to the app container, which has already imported Axios, which already knows how to do this work in order to submit it to the server. So what we're going to do is let's take a brief trip over to the app container, and we're going to say, I don't know, create new playlist. This new playlist function is going to receive the new playlist name, or whatever we want to call that variable. It doesn't have to match what we put on our state. Let's just call this new name. And what we're going to do is we're going to use Axios, which we already have imported. We are going to post to the URL /API/playlists. This is how we create a new playlist on our server. The body of this request, what becomes the rec.body, is going to be name is new name. And because this is an AJAX request, and AJAX stands for asynchronous JavaScript and XML, we know that this method, Axios post, is going to return a what? Promise, right? Because it's doing something asynchronous. It's doing something that it's going to resolve later. Once again, this is a very common thing to do with Axios. Because Axios resolves to a response object that has all this meta information like status code and headers, and usually we're only interested in the data, we just do res, fat arrow, res data to just say receive res, return res data, and then operate further down our chain like this. Once again, I mentioned errors. Listen for them. Even if it's just a console error, which is what we're going to do here. We don't have to have any kind of like, fancy construct like next in order to handle our errors. Let's just listen for them. That's sometimes all it takes, just listening. In this case, a console error if something happens. And this should be our new playlist. This should be a database record with an ID on it. So let's go ahead and see if that's the case. We're going to say console log new playlist, and that's all we're going to do for now. So this is now a new method on the app container, and we want to make sure that it gets passed down the layers. The way that we've set this up in the app container is a bit, it's a little bit prepackaged, but essentially we're taking the state of the app container, we're taking this object, which is sort of like packaging up some functions, and we're using object assign, which is an object merge, in order to set it as its props. And then it gets passed down the tree as props through this clone element. This is stuff from the React router part, so I'm not going to go too deep into it. But now we're going to say, what is the name of this thing that I called? Create new playlist. Create new playlist. We're going to say this, create new playlist. Just like that. So it gets made part of our what gets passed down. So now we can go to the new playlist container, and let's just verify before we move on any further that this.props has a create new playlist function. Let's just verify that that is indeed the case. It seems to be. That's why I'm seeing this function console logged out. It's something. So by the way, what we're looking at here, it looks very similar to what I typed, but it isn't identical. Right? Post, API playlist, name, new name. This whole Axios 2 default, what is this? Why is this here? Yeah. This is post translation by Webpack. This is how Webpack has actually translated the code. And it does things like the underscore and the namespacing and like the default stuff in order to control things like let and const block scoping for ES5. So that like only certain variables work in certain situations. But if you see like that discrepancy between your code that you've written and the code that you're seeing console logged out in this case, remember that Webpack is sitting in between what you author and what executes. Always remember that. That will be when you encounter certain problems, that will be an explanation far more than you expect it to. Yeah. OK, so we are handling this, which means that since we have it as a props, what we should do is we should say this dot create new playlist, which we receive passed down to us through the layers from app container. I'm sorry, this props create new playlist. We are going to invoke it with the name, right? So the new playlist name. So once again, this is the function we're talking about right here. This gets passed as props through the layers, eventually gets to our new playlist container. And then when the DOM component new playlist submits, we are invoking that create new playlist here. Yeah. So let's see what this does. Right now, all it's doing is it's not actually affecting our state tree or anything about our tree right now. It's just making an AJAX request. So what would you say is the best way to track if this is working correctly? I have reasonable confidence that I am going to have this function called correctly, but I want to see it go well. So what should I check?
Your database.
I can check my database. That's one thing. So the end effect as far as the signal going to the back end is there should be a new record in the database. I should check that. What else should I check? Like on the back end? So the route is already, like I could maybe put a console log on my back end. I could do that. Yeah.
The response code?
I could check the response code. How would I go and look at the response code? Would I console log out a value or?
In DevTools?
Yeah. Yeah, DevTools. Maybe it's something that you're not thinking about actively. Go check your network tab. AJAX request is going out. Go and look at it. Go and look at it. And then the last thing, obviously, is that it's going to console log out if it goes successfully. So I can go and check my console. But let's look at the DevTools first. That's always the first step. OK, we're going to type here. We're going to say 1701 playlist. And we're going to click this. This console log is a bit of a spoiler. It seems to have gone fine. But we can go to the network tab. Something that I very much suggest you do, especially when you start building larger websites with lots of requests and like images and crap, go to this tab, XHR, which is AJAX. XHR stands for XML HTTP request, which is what AJAX is called as a constructor in JavaScript. And then we'll see, oh, cool, that AJAX request. I'm going to go ahead and click on it and look, OK, it made a post request /API/ and it gave me a 201. So I can go and check that. And then also, as somebody mentioned, let's go look at the database and see if it got added. And in this case, yes, it did. So I got 1701 playlist. And I'm just sort of trusting that my backend works here, right? You've been given a backend. You hit the right URL with the right kind of signal. It should work. That's usually, like, if you become a front-end engineer in your next job, this is essentially where you stop and they begin, where the backend team begins. Is they're just going to tell you, here are your URLs for you to hit. Here are the methods for them. Here's what your signal body should look like. Just hit these things, and we promise that they will work. And that's just a very real thing. So this, even though you're not working on the back end for this app, this is actually pretty close to like real life. You're just sort of trusting that the right URLs will do the right things. And in this case, it did. So now we have another playlist in there. So we can go ahead and do that again and say 1701 again. And we hit that, and we should see another database record show up, 1701 again, because we've hit the right route with the right information. OK. Great. Awesome. What is next? Because I could probably get through that, since we are giving ourselves a little bit more time today. Yes, 1 second. Sorry. OK. Yes?
Before we move on, so as we're defining create new playlist on app container, how does our new playlist container have access to it? Is it a child in the routes?
The question is, we are defining create new playlist as a function attached to the app container. How does it make its way to new playlist container? The path there is a little bit confusing, which kind of sucks, but we can track it. Here we go. It gets defined on the app container. Here's our app container. This is where it gets defined. And then the app container, in its render function, is putting together this props object. So this props object, it's saying object assign, take this empty object literal, combine it with all the key values from my state, and then also combine all of the key values from this object, which in this case includes create new playlist. And this is going to amount to one big object with every property from the state and value, every property in this toggle, toggle one, select album, select artist, create new playlists, into an object called props. Now this object called props is, and this is where it gets a little bit more confusing, this is something you do with React Router. Because of the way that this route tree is set up, we think of our filterable artist container, or in another condition, depending on the URL, the albums or the new playlist container as being this.props.children. So we're saying if we have children, which means a route is activated, we're going to clone that child. In some cases, albums. In some cases, new playlist container. In some cases, filterable artist container. And we're going to take everything from this object that we've combined together and make it its props. Which is why when we go a layer deeper to the filterable artist container, we have this.props.artists, because the state has artists on it. And that's also why, in your case, the create new playlist function is available as this.props.create new playlist, because it's being passed down through this method. The problem with, the thing that's confusing about this is really this right here, this thing that we have to do with React Router. It sort of mystifies the whole passing down of information through the layers, but that's what's happening here, is that the layer we're talking about is being set as the child element, and we're recreating that child element and attaching props to it because of React Router. We have app container at the top, and then you see how everything's nested inside? Our child elements are whatever subroute is activated. So, but that's essentially the idea. Ian.
Does that propagate to those two sub-children, grandchildren?
Yeah, that's a great question. So Ian's question is, does that idea propagate to how the subroutes for artists work? And yes, it absolutely does. So let's go and look at artist, right? Artist is a child that's being rendered out by app container. So it stands to reason that if we look at artists, we'll see a similar approach. And we do. We do. We say, in this case, the children, not this.props.children because it's being set up here. We're saying if there are children, which meaning there is another subroute, what we're going to do is we're going to clone that and then do an object merge. Let's merge the props that were given to artists with these two extra things as well. So yeah, this pattern where you're seeing children and then clone element is because of React Router and because of the route tree having nested routes. That's where this comes from. Yes?
You wonder confused me there, because supposedly the children are rendering at this point, but then you also set their props instead of the opposite.
So the question is, it's a bit confusing that the children are rendering at this point, but we have to set their props?
Yes.
Okay, but that's always what we have to do, right? We're just doing this in sort of a weird programmatic way. But whenever we're rendering a child, for example, we have new playlist container, and one of its children, so to speak, is new playlist, we're passing in props, right? The props are always assigned and set where we are rendering out the component. So it actually is sort of the same. I don't know, maybe the way you're thinking about it, it could be a little bit backwards. I'd like to talk to you a little bit more about it.
First, and then we pass their props because it's
Well, the parent is rendering. And the only reason a child component, another layer would render, is because the parent renders it. So it's passing down in order. That is one of the things that if this is getting really, really confusing for you, that's common. React and going through the layers and having the props pass down, pass down, pass down, pass down through all of these layers, that is just, it's confusing, and that's how React works. But the thing about it is that's how React is going to continue to work. And after you start to understand it and start to feel more confident with it, you know that it's not going to change. It's still going to be the same sort of confusing passing down of layers, but once you've understand it, you can always know that's how it's going to work. So that's just a bit of, hopefully, motivation for you to continue and not be too sad. I do not have time to do more. So the next steps are rendering out all the playlists, right, in the sidebar, which is essentially just the app container on load. We can do that real quick. It's not too hard. I already have some code for it as well to put in the sidebar. OK, I have to add something to my sidebar. I probably should go to the sidebar.js, right? There you go. Great. And now we have some fake playlists that are being rendered out here, some playlist, another playlist, right? But we actually want to fill this in with real information. Something that my sidebar is equipped to do, but is not doing right now, is receive props. It hasn't had any reason to receive props before this point. But the idea now is that it's going to receive some props. It's going to be a list of all the playlists. So what I'm going to say is props playlist. I'm going to map that. And this is just going to be a list. And we are going to render out, or just return, so to speak, this kind of thing. And this is going to say, hey, go to, and we won't have the time to build this route, but we can say /playlist/ and then list ID. And then here we can say the list name, the name of the playlist, right? So we're doing that. We're not passing this playlist down, though, not yet. So what we need to do in our app container is we are going to add to this sort of like big thing that we were doing here that loads all this data, go and get all the playlists. So we're going to say Axios get, I'm just going to reformat here. Axios get /API/playlists. Don't need to use a template string here because there's nothing dynamic about this. That's fine. Go and get, oh, this isn't select artist. I'm sorry, I'm probably in the wrong place. There's another promise.all. There's another promise.all somewhere. Oh, is it in? Nope, there it is. Yep, great. So this is going to do go fetch all the albums so that we can list them out. Go fetch all the artists, we can list them out. Now go fetch all the playlists so we can list those out as well. So we have to change our onload a little bit to receive now one more bit of information, which is going to set on the state that information. We're going to say playlist, which could be written this way with ES6. We could just say playlists, but that's another discussion. We should probably also put on the initial state of our app container the fact that playlist is an empty array, so it doesn't break anything while it's being loaded. I will get to your question very soon. I just want to stay on this train of thought. And we are going to now have this.state.playlist, which then gets rendered further down. But actually, we want to pass it directly to the sidebar. So we're in the app container. The app container directly renders sidebar, regardless of route. So we're going to pass down playlists as a prop, and that comes from the app container's state. We say this.state.playlists, right? The AJAX call goes and fetches all the playlists, then sets it on the app container state, which is why in the render for app container, we say this.state as opposed to this.props. It's not being passed it. It knows about it. And now we have this list right here. OK. So going forward, we would build a view for one playlist, which is really just building another DOM component and another parameterized route with React Router and doing that. And then at that point, one more form with the song adder. But I am going to upload what I've done up to this point. There's a full solution, obviously. But there's also this. And I'm going to upload this and leave it to you as a challenge to finish those last steps. Because maybe you didn't get this far, and you've already seen how to do this. But you can keep going from this point. So I'll upload this separately for both of your cohorts so that you can go past this point. Yeah. It's just the nature of live reviews. It's hard to get through everything and answer questions at the same time. I went 15 over even. But I do have, I think, a little bit of time for more questions if you have them right now. Yes, Arnoldo.
We were calling our data in a very arbitrary way. Is it possible to use React to make it in something similar to an MVC structure, or you never try to do it to try to do an MVC application with React?
I would like for you to ask that. So the question is, it seems pretty arbitrary how we're storing data right now. Is there a way to do it in a more like React way, or like through like more of an MVC structure, which is sort of essentially our framework determines where data goes and how it gets shared with UI components. Ask me that question again after we've talked about Redux, because that is essentially what Redux is going to try to solve. Yeah. Essentially, where do we put data so that it can be shared across your application?
Before we start on Redux, so the whole setting the prompt thing we were doing earlier for the new playlist thing, you set the prompts. Does that need to happen in Redux before we start?
Yes. So the question is, so are you talking about specifically this here?
No, specifically about in the app container.
Okay. So the question is, how does Redux change what we're doing here with like the props and the state? I would say that what you should expect from the next workshop once we've learned more about Redux is the state that's being managed at the top level by the app container is going to in the future, after you've implemented Redux, move away from React entirely into something else, which then React connects to. So all of the state, all of the things that are global state to our application aren't in the top level component, but the top level component instead uses an external resource to manage that, and that is Redux. Okay, since the last two questions were about Redux, here's what we'll do. We'll take a 10-minute break, come back at 5:30. Make sure you're back here at 5:30, because I'm just going to start without you if you're not. And we will talk about Redux for an hour, and then that'll be the end of our day. Okay? So 10 minutes. Hey. Welcome back. Hello, hello, hello. Hello, internet people. I hope you are feeling extremely comfortable and snug today while the rest of us are out here. But it's probably a smart thing that you didn't come. Is the stream still on? I'll just ask in one of the cohorts. Mithun. Is the stream still on? Are we still good? Yeah? Great. Awesome. Cool. So let's learn Redux, which I will say with confidence, Redux is my favorite thing that we use at FullStack and Gracehopper. It's my favorite thing. Gabe's as well. I like it so much because it's small and simple and really doesn't actually have anything to do inherently with React itself. It's sort of like a separate tool. But it's like really interesting. Definitely my favorite thing.
Because it's like Dan Abramoff, the guy who wrote it, used very...
Hold on, Gabe. Hold on.
Oh, Mike's.
Yeah,
Hey,
Mike's.
yeah.
Which mic will go to the live stream? I would love Gabe to be heard. Bethune. Yeah, yeah. So that'll just be your mic, Gabe. You can tune in whenever you want to.
I was just going to say, I really love Redux because it uses concepts and practices from very strict functional programming, and it uses them in a way that, like a lot of functional programming, is a little bit confusing at first, but then when you see how it all fits together, you're like, why would you do it any other way? That's exactly the way it's supposed to be done.
Yeah, for sure. And also a little bit of interesting history about Redux. Redux was invented because this guy, Dan Abramoff, who created it to begin with, just wanted to give an interesting talk at a conference. So he was like, here's this basic idea that I've been thinking about. He created this library, he presented about it, and people were like, whoa! And now it's like this huge thing, and now we teach it at FullStack, which is like incredible. Redux is all about this word, state. It's all about this word. And I have a lot of difficulty, and I've tried before, because it's my job. But I have a lot of difficulty trying to explain what state means to people like you, like students and new developers. What does state mean? What is state compared to other things? So I like to talk about it through this vehicle of this game that you might have seen before called Pong. The idea with Pong, if we were to think about it as a program, is that there are many variables in this program that can be considered state. There are other variables that we could consider properties. So like the philosophical difference between props and state is sort of like if we look at a chair and that chair is black, right? Like a black chair. That is a property of that chair. But something that might be the state of a chair is whether or not it's being sat in, right? Somebody's sitting in it. That is the state of the chair. It's something that is ephemeral. It's something that can change based on some kind of action. And that, in case action, is somebody sitting in it. So there's certain things about what we see here in Pong that are properties, things that will not change no matter what. What are some of those things that will not change? What about this game doesn't change no matter what? John? Yeah, I would say because of maybe like a screen size, the dimensions of the game, right? It's going to be X large and Y large and X large, right? And we're going to have like a line in the middle, and then we're going to have two paddles and a ball, right? And the score is going to be up there. And those are things that just don't change, right? The positions of those things don't change. What else wouldn't change about the screen? These things that don't change are considered props, yes? Right, the menu button's probably going to stay here. Maybe we can consider it possibly changing if it like, I don't know, but probably not, yeah. So that's something that will stay the same. What are things that are not going to stay the same? Yes? The placement of the ball, where the ball is at any given time. And we're going to talk about what might change that, but yes, I would say where the ball is, which really boils down to what? The X and Y coordinates apply to the ball, right? Where should the ball be? This X, this Y on the screen. What else changes over time? Maria? The points, right? When we score against another player, the scoreboard, even though the scoreboard is in the same position, that scoreboard will change its state, right? Right now 4-0, maybe it'll be 4-1 in a couple seconds based on who is going to win this point. what else changes? Jess?
The y-axis of the paddles.
Right, the y coordinates of the paddles. And not just one of the paddles, but both of the paddles, right? And they have sort of their own y coordinates. Yeah. What else? That was your answer? Okay. I was going to call on you next. I'm sorry. Anything else you can think of? Maybe it's beyond this screen, right, James? The direction of the ball, that's interesting. So maybe we can consider, right, so where the ball is x and y, but it does have some velocity in some direction, right? So maybe that can be considered state, how that state is going to change, right? Is it going to be moving to the, like, this way at this angle or this way, right? That could be part of state, yes?
If you're playing with a computer, like difficulty.
Yeah, if this is not another player over a network or on the same control, but like a computer player, it could be that the state of the difficulty of the computer player is there. This is also just one game screen, right? Maybe the whole entire reason we see this is because the state of the application says we are in the play mode, whereas we're not in the menu mode, right? So the fact that we're even on the screen is sort of part of state. So there are some things that are not determinate in this and some things that are. The things that are determined are things like position and colors and aspects, but there are things that will change, and that's what we consider state. I like to go through that exercise because I want to get across that state is something that you can track in a list way like that. You can say that state in my application, this is a finite list of things that could change. Paddle position, ball velocity, score, game state, right? Like, beyond that point, we don't think of anything else being changed by any kind of actions. And we do have to talk a little bit about global versus local state first. So some dynamic information about an application may be generated and used by some kind of global state. Or it could be by one single component. So an example of this, let's say we're working on a game. We have this countdown component. This countdown component is meant to essentially, like, let's say we use the countdown component and we provide a props of like minutes 5. So its initial state is going to be 5 times 60, so that many seconds. So it'll be 3,000 seconds. And it's going to count down a set interval, set state, to be second minus 1. Seconds minus 1. This dot state seconds minus 1. That is internal state. The countdown doesn't need to share necessarily that state with other parts of the program. But something that it might want to share with the rest of the program is if that game countdown, that timer that is decrementing, and that internal state that's making those seconds go down and down over time, if that is going to eventually signal a state of game over for the whole entire application, that's what the countdown might do, is we're decrementing down, and every time we decrement the remaining time, we check to see if it's 0. And if it is 0, we are going to set on the global state game over, which a lot of the application is going to want to be aware of, right? Because that might change us going back to the menu screen, or us showing who won, or even checking to see who won. So that's global state. That's something that's a little bit more categorized for the entire application as opposed to one tiny thing. And this has a corollary to what we've been doing with inputs, right? With input, we say on change. And usually when we say on change, it sets the local state of some container, right? While it's packaging. If you think about the credit card form example I went through in the forms lecture, we were sort of using the credit card form, which was a smart component, to set this dot state, this dot set state, to start packaging the credit card number and the type and the CCV. But it wasn't until we submitted that we made that packaging of that internal state made global, passing it up to the app container so that it can be operated on, something that the rest of the application would be interested in. So that's just a little bit of a distinction to keep in mind. I'm sorry, I have an extra slide in here that I meant to not show. So on top of us thinking about our application having sort of finite global state, we can also think about how state gets affected. So same screen, and I have some very artistic shapes in here now. But we can think of, okay, if part of our state is the y-coordinate of the paddle. What determines the y-coordinate of that paddle? What affects that state in the case of this game? The user's input. Yeah, the user's input. Us pressing up and down on the arrow keys, or moving our joystick on our controller, or if you're building a Pong game that is like built with like Connect or something, it's like somebody like squatting up and down. But either way, it is a input to control this state, which is what is the y-coordinate of paddle 1? What is the y-coordinate of paddle 2? The position of the ball is going to be based on, in this case, something that is important to understanding how to program games, the game loop. Essentially, this thing that runs at a very, very quick interval, which calculates the next state of the game. In this case, it takes the velocity of the ball going in any specific direction and updates the state of its x and y value to be what it should be next, right? So the game loop makes that ball go across the screen, just sort of this thing that calculates in a loop. Same thing with the scoreboard, right? If the game loop means that the ball is going to go past the dimensions of the screen, that means whichever side it hit, that player should get a point. So the game loop is affecting that as well. And those possible actions to affect state are extremely finite. We can say, here are the 7 actions that can affect state in our game, so to speak. Paddle 1, move up. Paddle 1, move down. Paddle 2, move up. Paddle 2, move down. Ball should move. Paddle 1, gain point. Paddle 2, gain point. Some things that are probably missing here are go to menu, right? Like change the play state. But for this app, and I know it's a simple one, we can basically break it down to that. Those are the only things that will stay dynamic about our game. Everything else is just set in stone. Those are the only things that will change. Does that make sense? What are your questions about that? That's my best attempt so far to explain what state is for a program. And that's what Redux is all about. Redux is a tool that is separate from React, that is meant for organizing and managing state. In fact, it's really just sort of like a really, really controlled object. That's what all Redux is. So, what Redux is, it's a very, very small tool for containing, accessing, and affecting a set of information, often called state. So, it is an effective player in the architecture of building large applications with React. But it is not something that was built by the React team. It is not something that was built even with React in mind as a primary goal. Maybe. But still, it is totally separate from React. And as Gabe mentioned earlier, it's a good gateway drug to strict functional programming, which is something that I really love, Gabe really loves. A lot of the instructors really love functional programming, although it can be sort of a big obstacle to jump over to start to understand. But this is a great way to start, because now we're going to start using some of the concepts of functional programming, which I'm going to talk about, in our React apps. What Redux isn't. It is not a React-specific tool. In turn, it is not React Redux, which will be the last thing we learn on day 5 of Juke after this, React Redux, which is a bridge essentially between React and Redux and how to use it to create smart components that listen to Redux. It is not tremendously valuable in a small-scale application. So something that a lot of people think to begin with is, because I have Redux, I should use Redux. Not the case. When you are going to integrate Redux with React, there's a whole bunch of verbosity and boilerplate you have to set up in order to get it to work. So it isn't actually always the best thing to use. There are lots of React applications that I have built in like the past couple months, and I know Redux really well, that I just decided not to use Redux for, because I thought it would be more work than it was worth. So it isn't very, very valuable when you're building something small. I would say that Juke is sort of like at the point where it's questionably valuable even then. We just can't give you a workshop that's gigantic, right? We can't make you work on a workshop or on a code base that is as large as Redux becomes valuable for. So you sort of have to drink the Kool-Aid on it. But still, it's like, if it's too small, Redux is just going to complicate things. It's also not the only game in town, meaning There are lots of other libraries that have the same ideals as Redux that are not Redux. There's another one called MobX, which has a couple new features beyond Redux that a lot of people use with React. There are people who have built Redux type things that are smaller than Redux and do less than Redux. I have a 25-line piece of code that I'm going to show to you soon, which is essentially Redux without a whole bunch of its different features. But it's not the only library that does this. So let's do some live coding. I am going to show you what this Redux thing means. So let me just make sure that... Did I just hear somebody say geez? Or was that a sneeze? It was, OK. So here's some code. And this is just getting started with Redux. You npm install Redux. I don't have to show you that. It comes from npm. It gets imported into our code. And this is usually the only method that you really need to use with Redux, other than its ancillary features, which you will learn during the workshop. I'm not going to lecture about it because there's sort of like extra features that you can use, but it's not at the core of how Redux works. The idea with Redux is that, I'm just get rid of this for now. Let me take this and put it in a comment so I don't have to go and copy paste it again. The idea with Redux is that you have this create store method. And what this create store method is for you to create essentially an object that can only be interfaced with through what is known as actions. So here's what we can do. We can say, let's create a store. And a store is created by calling getStore. And I'm just going to do this function in here. We'll talk about what this function is, and then we're just going to leave it at that. So now our store has a method on it called getState. And I'll just show you what this does. So right now, we just get undefined. OK? Doesn't seem to do that much right now. So what I'm going to do is I'm going to take this function. This function is called the reducer. It actually looks like array reduce a little bit, in that it takes what the state is currently. So when you use array reduce, what do you receive as the first argument in the reducer function? Yeah, the current value, what's been accumulated before it, right? Or the initial value, right? And then the second argument is the current element in the array as you're going through it. In this case, it's something that we call an action. And the idea is that this function, receiving what the state is now, and the action, the signal that's being passed into Redux, is going to determine the next state. So here's what we're going to do. We're going to say that we have an initial state of x0, y0. OK? Initial state of x0, y0. So this is just the state of our application. Let's say we're just building an application for one of the paddles in Pong or something like that. OK? So what we're going to say is that the default state, the thing that the state should be to begin with, is that initial state. So this pattern, I'm just going to explain this to you now. This is an ES6 feature called default parameters. The idea here is that this is a function, right? This is a function. And we're saying that if state, if this variable that we're calling state, this parameter calling state, is going to be undefined, what it should instead be is initial state, this object. So this is what it's called a default. Other languages have had this for years, but this is brand new to JavaScript. And the idea is, rather than you checking if not state, OK, then state is equal to this. You can just do it in the parameter list. So this is essentially the same thing as doing this for clarity. We say, if type of state is undefined, then we're going to say that state is actually equal to initial state. So by doing this here, it's the same thing. OK? So if the state's undefined. And now what we're going to do is we are going to essentially operate on these actions here. So our state is going to start as an object x and y. And what we're going to do is we're going to do this. We're going to say, let's use a switch statement. Remember switch statements? Have you seen switch statements in a while? Switch statements are making a big comeback with Redux. I like switch statements, but as a review, the way a switch statement works is, let's say that we have var name is Joe, and we can say switch name. In the case of the name being Joe, then you should say console log, hello, dark-haired teacher. I fucking know what I'm doing right now. It's been a long day. And then if name is Gabe, console log, something about swords. I'm sorry, Gabe. I don't really want to pigeonhole you. I just can't think of anything clever right now.
That's okay.
And then default is just like console log, I don't know you, right? I don't know you. And we just want to make sure that if it is one of these cases, that it doesn't fall through to the next cases. So what we do is we say break. So we say break out of the switch statement. So this is a switch statement. You've probably seen them before. You just haven't used them in a while. But it's essentially a way for you to do multiple conditions based on a value. So we're going to be using a switch statement here. We're essentially expecting that our Redux store, the thing that is organizing our state, is going to be signaled with many different kinds of actions, what we call action types. So we have our state, which is what it is now, x and y, 0, 0. And we have an action that is meant to change the state in a specific way. So what we're going to do is we're going to say switch action type. And we're going to say, in the case of the action type being move up, and let's say 1, we are going to say that the state y value should be state y plus 1. OK? And then we say break. In the case of this action being move down 1, we can say state y is equal to state y minus 1, right? Break. And let's just keep it at that for now. If we are receiving an action that we actually haven't registered a case for, we're just going to say, you know what? Return the state as is. And then down here, we just say return state. So for those of you who've done some pre-reading, you might notice that I'm doing this wrong so far, but that's OK. I'm going to be talking about why this is a little bit wrong, but it doesn't change what is right about it. So the idea now is we have this Redux thing. It starts as this object. And now we have a function, which we call a reducer, which is meant to receive signals with these action types and then change the state of our object in different ways. So this is like a regular object in JavaScript. But a regular object in JavaScript, we can just like set properties on it. We can just say x is equal to this new thing. But in this case now with Redux, is we've registered certain actions that can be taken that change the state in expected ways, in registered ways. So now what we can do is let's go ahead and look at store get state on line 41 here. We're going to console log this out. And this looks like this now. X0, Y0. But now what we're going to do is we're going to use another method on the store called dispatch. And dispatch is a way for us to send a signal into the reducer saying the state should be updated. So what I'm going to say is send in an action with the type move up 1. And now after I've done that, I'm going to take the store again and call get state. Right? This is Redux. Like this is it. Like this is what Redux is. The usage of Redux with React gets a little bit more complicated, but this is all Redux is rather than you setting up an information set like this that can be mutated in random ways, you instead set up this information set that can only be mutated by sending in actions, sending in signals that are categorized and do expected things. So let's do this a couple more times. So we're going to say move up 1, move up 1, move up 1. As you might expect, we now have Y3. OK? That's what Redux is about. We send signals. It updates this information set. The other thing that Redux attempts for us to do, but can't do by default, is we want it so that every time our state updates, it becomes a new information set. So what we're doing right now is actually bad. Because what we're doing is we're taking the same state object here. And every time a signal is passed into our reducer, we are changing the property on this object. What we want to do instead is we want to create a new object and have that be the new state. So the idea here, we can do this in a whole bunch of different ways, but let me do it in a bit of a manual way. We're going to say that we are going to set const new state. Const new state is going to be x, the current state, x, and y, the current state, y. So we're setting up a new state. We're taking information from the old one to provide here. But now what we want to do is we want to say the new state should be equal to the new state y plus 1. So now we don't change our old state objects. We're just affecting this new state object. Same thing here. New state y minus 1. And then down here what we want to return is not our old state, but our new one. But in the case of an action not being recognized by our reducer, so it's not move up 1 or move down 1, we just want to return the old state because nothing has changed. So now what this does is not only do we have an information set changing as we send signals into it, we are encapsulating and freezing in time any certain step of our state. So if it starts at 0, 0, and then a signal comes into this information set to say move up 1, we now have a new object that's y1, x0. But the old object is still there. The old object is still there. So let me show you how this is useful. By the way, there'll be a recap of all these different things. I know I'm going pretty fast right now, but I want to show you why this is cool. So let's say that, all right, let's bring some React into this. Let's visualize some stuff. So I'm going to say I have a app thing here. So I'm just going to go to this main.js. I'm going to say bring in React DOM render. So import render from React DOM. Your import should be at the top of your file, but it doesn't really matter, just for organization purposes. And I'm going to say div. You know what? I'll actually do this in a different way. I'll do this in a different way. There's another thing you can do with Redux, and that is sending signals in. You can get state out, but you can also listen for when the state changes. So here's what we can do. We can say store subscribe. Subscribe. We can say when your state has changed, when a signal has come in to change the state, you can react to it. So we can say here store.getState. So now let's say that instead of 3 times manually, we instead say every second, using a set interval, every second, we are going to move up 1. We'll get rid of this. So now, just every second, there's going to be a signal into the Redux store with move up 1. And what our store subscribe is going to do is it's going to run this function that we've given to it every time the state updates. So let's see what happens. Right? So we subscribe to that state changing. Cool. Very cool. And now what we can do is we can do something like this. Let's render to document get element by ID app. Now let's just create a bit of JSX here. We're going to say that this is a div. No custom components, just using React in a very simple way. But we're going to say here the h1 is going to have store get state x. And this h2 is going to have store get state y. So now every time our state changes, we're re-rendering this div with the h1 and h2 and showing information from Redux. It looks like we have a bit of an error here because I forgot this comma. Cool. React is not defined, of course. Once again, you know the reason for this, right? JSX. OK. So now, every time our state changes, we get this. I know this is a bit silly. But it is an information set being visualized, and the only way that information set gets changed is not by us doing unchecked, unmonitored, insecure mutations to it, but sending in signals that have categories that it expects. The other thing that happens here, so what I'm going to do is I'm going to have this happen like 3 times or something like that. I'm just going to say set timeout after a second, then after 2 seconds, then after 3 seconds. It's silly stuff, but okay, so that 3 actions. 3 actions get sent into the store. Move up 1, move up 1, move up 1. It changes the information set from x0, y0, then into x0, y1, and then x0, y2, then x0, y3. And the thing is, because each of those states was calculated from the previous but did not change the previous, we can do some neat stuff like track it. So what I'm going to do is I'm going to put this DevTools extension thing in and show you some of the power of what's going on. I'm just going to add this into here. So this is a Chrome extension, which I recommend you use in senior phase when you're working with Redux a lot. But this Chrome extension knows how to interact with your Redux store to track the things that have happened to it. And what this allows for us to do is, first of all, here's the initial action. This is something that Redux sends in on its own when you start the store. But then you can look at the description of the first action that happens to your store. So the action looks like this: type move up 1. The state that is generated out of that action is x0, y1. The diff is this: y changed from 0 over to 1. Right? So if you imagine that this is like part of your app or something like that, we think about real actions. It's really nice to think about Redux through a game, but let's think of something like a form. Some of your Redux actions are like when somebody types in an input, you are sending into Redux a like credit card number updated. And you can have like every keystroke send in this object. Something you can do at that point is, if you are testing and you're developing, you can just take those actions and recreate them when you want to test. Or in this case, how about we do this? What I'm going to do is I'm going to take this second action that happened, the one that changed y from 1 to 2, and I'm going to, in this, click skip. And now this looks like a 2. Now this is a 2. And then I can say, oh, put this back in, and it turns into a 3. I can take out 2 of these actions, and what do you expect? That y is 1. Right. So now we're thinking about the state of our application. Remember Pong, where the paddle is, where the ball goes, what the score is, and thinking about it as a set of finite actions. And because of the way that we're sort of categorizing these actions and keeping track of them, we can sort of determine what our state should be coming up, store and freeze previous states that have happened in the past, and then see how our app reacts to getting rid of certain things. That is the idea. Let's do some questions. Yes?
What's the name of the Chrome extension?
The Chrome extension is called Redux DevTools. Yeah. Redux DevTools. Yes?
But, I mean, like it's really cool that we can basically take a complex action and break it down into all of its frames or bits or whatever you want to call it. But at the same time, doesn't that limit us by saying that we do have to take even large-scale actions that we could normally do in one step and do it in all of these steps? So wouldn't it slow down? Like, let's say we have to do, instead of move 1 at a time, it's moving 50 at a time, or whatever it is. Or it's various like random movements or random increments or something of that nature. Wouldn't it be slower to have to wait or to comb through the program doing one step at a time as opposed to seeing each, you know, group?
Gotcha.
Or,
Yeah, gotcha. The question is essentially, isn't this like sort of like a small increment? Wouldn't we have to do like a whole lot to do something like small through this? But that's only because of the way that I've written my actions, based on how I'm understanding your question. Because yes, we have right now two actions that can affect the state, and I've just called them move up 1 and move down 1. But that doesn't mean that we're limited to just supplying a type. So let's do this. Case move right and just move right. And the idea is that the new state x is not going to just be +1, but it will be based on something that's passed in via the action. So what we can do here is we can say, all right, we are going to move up 1, but let's take out this second one, and we're going to say move right, and then how far? Let's say 50. So it can be part of the signal. It doesn't have to be like 1, 1, 1, 1, 1. We don't have to set up types for every single increment because our actions, including a category, which we know as a type, can also have what is known as a payload, some data attached to it. So now what happens is we have this. I'm gonna make this a little bit smaller. The only reason I'm doing this is to find Redux dev tools looking at it. Right? So now we can say increment by some kind of dynamic number that I provide at any given time. And we can go back to Redux DevTools and we can say, here are the 3 things that have happened to the state of my application. Isn't that fucking awesome? Like you can just like look at like here, this state of my application which controls everything that it visualizes. I could have that happening without any kind of monitoring, or I can use a tool like Redux, which controls every step and how it changes, and essentially gives us something like a Git history, right? Every time you make a Git commit, your old commits don't go away, and you can always roll back to those if you want. And we can do that here too. We can say, let's just jump to when the only action that had happened was move up 1, and now we have 0, 1. Okay, good thing I checked that, so I know what my application looks like at this point. Let's go back to its latest version. Or you know what? We probably had a bug here and we shouldn't have moved right. So I'm just going to skip and have that one not work. And it sets the x to 0. So now we can think of this state, which I know is very contrived and small right now, but we can track it. We can monitor it. We can see what the effects are step by step by step. That's what Redux is about. It gives us predictability to the changes of our application because we make it go through this single source, which we know is the store. Yes?
So you're tracking it with this dev extension. Are there methods on the thing itself that you can somehow like jump back?
So I'm tracking the changes with the dev extension. I'm sorry, I'm just repeating for the remote people. I'm tracking the things with the dev extension. Are there ways to do this just with Redux? Yes, but not directly interfaceable. So there's an extra sort of concept in Redux called middleware, which is how this extension is working right now. Essentially, every time my state is changing, it's grabbing that state is currently and then storing it into a separate collection in the Chrome extension code. So it like remembers as the states are changing what they used to be, and then replaying and unplaying actions based on that. But there are ways to get in between and gain access to it. So yes, the answer to your question is yes. Okay. Let's go to some slides which talk about these things in human language. The store. This is what Redux is all about. It's the store. The store is a singular holder of information. In our example, our information was what? I can't do a Y. X and Y. X and Y, just X and Y. But in a real application, the information will be like artists, albums, selected artist, current song, is playing, right? All of those things that our application, something that isn't dynamic about our application is whether or not a player exists that can play music, but whether or not a song has been selected and is playing. That's part of the state of our application. That is what is going to be controlled by Redux in the workshop when you work on it. And Redux is just a holder of all of that changing information, all of that information that can be dynamic. In our case, it was just X and Y. The store can receive dispatch signals, essentially like function calls, so to speak. We say store.dispatch, and we call those signals actions. Those actions are just objects with a type property. Just saying, here's an action, here's the type. It could have other properties like we saw with the how far, but that's all they are. It's just signals into the store. The store receives those actions and then mutates the state, mutates the set of information. Actually doesn't mutate. creates a new state of information based on that action and its description. And then it provides an interface to access the state as well as listen for state changes. So access the state is get state, and listening for when the state changes is subscribe, which we saw in the code already. So,
Joe,
yes.
I slacked you GIFs that has those very popular GIFs of the kind of flow through Redux.
Yeah, I'd have to figure out, oh, totes, yep. Cool. Let's bring up one of these. Yeah. Cool. The idea here is that, let's ignore this part for now. We have actions. These are store.dispatch, and they send actions into the store. The dispatcher receives those actions, right? That's what dispatch gets dispatched to. It then calls our reducer. So our reducer, which I have a slide for after this one, is that function that I set with the switch statement. And it figures out, based on the type of this action, am I interested in updating the state? And then the state, based on that, gets updated, which then can be used in our UI or in our application or something like that. And our application can send more actions. The idea here is that the store is a controlled information set. It cannot be mutated directly. It can only be sent signals, and it will base changes on those signals.
I want to add a thing to that, which is...
Do you have a mic on?
I'm supposed to. I believe so. Yeah, I can hear it.
Yes, but is that... OK, great.
Yeah. One of the really huge wins for this kind of structure is that instead of every bit of our UI and our application spread throughout, figuring out how it wants to modify state and making assumptions even about what the state looks like, in which case, with a larger and larger application, some part of that code base is going to be out of sync, and it's going to think the state is supposed to look one way, but in reality, something else has changed it to look different, or two things are going to be interfering with each other. It almost always happens that way. And if you want to change something in that old structure, you have to go to every single part of the UI that might be altering the state and change it to alter the state in a different way. And that gets extremely difficult and very easy to make a mistake. Now, all that our UI is going to do is signal something happened. And the UI doesn't even know what should change as a result of that. All it's going to say is, here's what's happened. Every single thing that can change a state is going to be centralized in one place, which means all the logic for it lives in an easy to wrap your brain around place, and you can be very strict and disciplined about updates to that and changes to that. And if you want to change it, now every single piece of UI that signals to the store, they're already up to date because they didn't know how you were changing the state anyway. So lots of advantages to this system. That
centralized place in which information changes is essentially just between lines 27 and 37 here. I know it's small. But we can understand in a complete form how dynamic information changes on our app just by looking at this. You can either move down one, you can move up one, or you can move right an arbitrary amount based on how far. This is the entire story of our application right now. And that's what Redux does, is gives us that centralized place that is contacted that then changes that information. Zoe?
Is this stored persistent, or is it the states, do they, if you refresh or close the app and bring it back again?
Zoe's question is the store persistent, or when we refresh the app, does it go away? The store is an object in JavaScript. So yes, it goes away. It's not persistent like a database is. It doesn't store anything outside of the browser program. So if we refresh, program is terminated. Everything that was assigned in that program, arrays, objects, variables, everything, gone. Kaput, forever. And then it starts back up. Yeah, Arnaldo.
Redux is a library that helps us to maintain the state of anything that we want.
Yeah, it doesn't have to be used with React. It could be something that, if you just want, maybe even on your back end, you want to have an information set that shouldn't be changed in random or arbitrary ways. You just want to build that information set, build a reducer which defines the actions that can change it. You can just do that. It doesn't have to be used on the front end at all. It could be a back end thing.
I want to add actually onto what Zoe asked a second ago.
Mm-hmm.
Were you about to go into loading the state serialized on load and JSON and that kind of thing?
No.
Okay. So Zoe, as Joe pointed out, when you refresh the app, you're starting your app from scratch. All the JavaScript memory is starting from a blank slate, and you start over. But there's a really awesome thing that I love about Redux, which is that since this reducer is returning a new state object every time your state changes, it's a new object. And Redux is actually collecting that as a series of objects. And the rule with the way you're supposed to use Redux is that state object, ideally you should be able to turn it into JSON. The reason that's awesome is because if you stick to that rule, you stick to only putting stuff in the state that is like serializable and deserializable, we can use a technology we haven't taught you about client-side local storage, where Redux can save all those state objects into the browser. And then when the app loads up again, it'll ask the browser, hey, did I save anything here? And the browser will say, yeah, there's all these state objects. What do you want to do with them? And Redux will stick them back in the store, and it's like you never left. And in fact, not only is it like you can refresh and you still have all the state, but you can go backwards to earlier states and forwards and go backward and forward in time and see your application being used and unused and debug that way.
Yep.
It's pretty incredible.
And that's because the information, the object, is something that can only be mutated by these signals. You can store these signals and you can leave them for later and recreate. Exactly. It's determinate. So I'm going to continue on because there's a whole bunch of other slides I want to show you. So once again, the store is that holder of information. It maintains X and Y. It maintains the album, selected album, is playing. Everything that might change about our application in one place. It can only receive signals, which we call actions, to affect that state. And it provides an interface for us to ask for the state and then also listen for when it's been changed. The reducer is this function right here. It's this function that we've written over here. And I'm going to write this in a different way because I know fat arrows can really muck up things sometimes. Done. OK. Same thing. OK? So we call create store with this function. I'm just going to highlight this function in full. This function is called the reducer. And the reducer is a component of the store that decides, based on the signal being sent to me, which we call an action, what should the new state be? That's what our switch statement is about. You don't have to write it as a switch statement, by the way. You could do a whole bunch of if, else if, like whatever, however you want to do it. All you're doing is checking the action type and responding to the action type as a condition. If you wanted to make it part of like an object, like have a dictionary object with the different types, that would also be fine. Switch statement is just convention that a lot of people use. But the idea is if the reducer knows about a specific action type, it will define logic of what the state should change into. So in the case of an action type being move up 1, I should create a new state object and make the y value plus 1 what it was before. In the case of it being move right, I should check the how far property on the action and make the x value on this new state object x plus however far that number was. Okay? It creates a new state per action rather than modifying previous states. Because if you modify previous states, if you make mutable operations on the properties of those objects, which is up to you, by the way, Redux can't possibly keep you from doing this. But if you don't modify those previous states, that means you can activate things like time travel, where you say, you know what, those 3 actions, those are part of like a bug in my program. So I'm going to revert back to the first action that was taken, or get rid of all the actions and make my form empty, so to speak. Different ideas. This really makes sense when you're like thinking about building games, by the way. Like you can imagine, you can essentially imagine that your player will like control it in different ways and have these different actions which affect the state, like the position of what they're controlling or whatever. And you'd be like, okay, I want to get the player to this specific point in order to test this new feature I'm building. So I can just recreate their actions and get them there to that state, because the state is predictable. The reducer can also, in some advanced cases, be either replaced, so you can start a store with one reducer and then replace it with a new one, which isn't a very common thing to do, or it can be chunked. It can be broken up into smaller functions rather than you having one big reducer, which is one of the ancillary features of Redux. There's 2 things that we haven't told you about Redux, And that's it. You know everything else about Redux. That's how small it is. This is the last two features you need to know about. One of them is called combine reducers. This is not something that's available off of the store, but something that you use to essentially build many reducers and then combine them together into one master reducer. So you can start to break up that functionality. You'll be doing this in the workshop, so I don't want to harp on it too much. The other thing is middleware. Middleware, like the DevTools thing that I'm using, you'll see in my code how I ended up using this. I pass it in as a second argument to create store, this expression, which is essentially just, let me just simplify this a little bit without the conditional. Just this. This is middleware. So middleware is this idea that you can put a function in between your action being signaled into the store and it actually being received by the store. So somewhere in the middle, called middleware. So you can, which is different from express middleware, by the way. But the same idea is that you have the beginning of a pipeline here, and you have functions in between that can say, go towards the store, right? And you can sort of like intercept these actions a little bit. So a very, very common middleware that you will be using in the upcoming workshop is a logging middleware. So you can essentially just see a console log of every action that gets sent into your store. It just sort of intercepts that action and logs it out. Let's talk why you want to do things in an immutable way. Why do you want to create new states? And what purity is. So a new state. It's imperative that your reducer produces a new version of your state rather than mutating the previous one. So there's all kinds of unintended side effects that can happen if you're basing all of your information changes off the same object. That's just because of JavaScript, right? When you change an object property in JavaScript, anything that has reference to that property also sees that change, but implicitly, right? Once it tries to access it, because they're all referencing the same object. And then, as I mentioned before, maintaining history and time traveling, saying these actions happened in my app, it made the state look like this. So if we create a new state, every single action, we can sort of like plop some out and then see what the state would be based, what it would be like if we didn't take those actions in the first place. So think of it like a Git commit. It's like a Git history. You can sort of like scrub back and forth through it, which is really nice. So operations that will mutate a state object or things that are part of the state, just to keep in mind. Things that will mutate. Adding, removing, or modifying object properties. So if you put a new property on an object, or you change the value of a property, or you remove a property, you are changing that object. That will mutate the object. If you're working with an array as a value on your state, if you push into that array, or if you shift, or if you unshift, or you pop, or reverse, or splice, and some others, that will change the array you have, not produce a new array. It will change the array that you have right now. And if you use object assign, which you have seen through these workshops, it's an ES6 feature. It's just essentially merge objects. If you use it the wrong way, it will mutate. If you use object assign, let's say you have an object with x and y, right? And you put that as the first argument of object assign, and then you put as a second argument to object assign y1. The y value on that first object is going to be replaced, but you're not going to get a new object. The first argument is going to get mutated, which is why when you use object assign, you usually see that first empty object literal. So staying immutable, here's some tactics you can use. You can do this first thing. This is very, very common. You say object assign, an empty object literal. This is going to be your new object. This is the thing that is basically giving you immutableness. Immutability, there you go. This empty object, and we're going to say, here's our previous state. I'm going to add every property and value from that previous state onto this new empty object, and then I'm going to replace that previous state values with the ones from the new one, from the new properties. So instead of you combining one object into the first one and changing that first one, you start with an empty one. So that allows you to create a new object while changing some properties. Rather than doing a push, what you can do is you can use concat. You've probably already been burned by the immutability of concat, right? You've probably tried to use concat and expected it to update the array you had, but it doesn't. It returns a new array. In this case, that's a good thing. You get to take an array that you have, add an element to it. Now you have a new array with that element added, and that old array is untouched. It's good. Another way you could do that concat is by using the spread operator from ES6 with an array literal. So you can say, here's an existing array that you have, list of items. You can say dot, 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 list of items, and then the new item. And this will create a new array that includes all the stuff from the old one and then the extra thing, right? Another aspect that Redux really, really, really has at its heart that comes from functional programming is functional purity. Functional purity is sometimes more formally called referential transparency. But it's this idea, it's a pretty simple idea, that a function that gets invoked with the same arguments always produces the same output. So the simplest thing we can talk about in that way is an add function. You call add with 2 and 2, you will get 4. You will invariably get 4. That is a pure function. No matter how many times you call it with 2 and 2, you will get 4. But if we wrote our add function for some reason like this, x plus y plus math random, now if we call this function with 2 and 2, who knows what we're going to get? It's not deterministic. We don't know based on the input what it returns. What are some pure functions you've been writing in the past 2 days? Dumb components. Dumb components. Yes, dumb components. That's correct. It's 6:26, I know. Dumb components are pure functions. You call them with the same props. They should visualize in a deterministic way. They should always look the same if called with the same props. It's a pure function. The other thing that makes a function pure is a lack of side effects. So let's say that we have our add function, pure function, but let's say in another case, for some reason, our add function, in addition to returning x and y, which would give it referential transparency, it does a little extra sort of silly thing where we have z defined outside the scope, and then for some reason z becomes what y was passed into here. That's what is known as a side effect. This is a bit contrived, but this is what a side effect looks like. Your reducer should be a pure function, meaning that it should never be working off of any closure variables, unless that's a module or something like that. It should never be maintaining state outside of the state object that it receives. It should always do the same exact thing based on the action and the state that it's receiving. You should always have the same exact output. Your reducer should be a pure function. Some common things that will lead to impurities are things like AJAX calls or socket messages. If you have your reducer making an AJAX call, that is indeed a side effect. You are sending a signal to a completely different other program through HTTP connection with some information. That should not be in the reducer. That should be in the action creators, which we'll address in the workshop. Any kind of randomization. Any kind of randomization. So let's say that we had a action. Let's do this in the code, actually, just real quick. If we had an action in our reducer called move left random, and then new state x is equal to new state x minus, and then we did like math floor, math random times 50. So it's going to move like a random amount between 0 and 49, right? This is not good. I think it comes from a good place, but this is not good, because now when we send an action called move left random into the state, it's going to produce a random output, right? The first time we send the action in, it'll be like x is minus 47. And then the next one we do, it's going to be x is minus 54. And then if we were to get rid of those two actions and do them again, we'll have a different result. That makes it impure. That makes it random. So the better way to do this is figure out the random number you want to move before you send the action in. And then make it so that it can be arbitrary. The point is the reducer should stay pure. And then any usage of any dynamic closure information. Like, let's say you have like a let variable outside of your reducer, and then one of the actions will set that let variable to be some value, which then gets used in a later action. That's bad. Always make the operations of your reducer based on the state that's being received in and the action. How Redux interacts with React, you will see in the workshop. But what you've seen now is the full story of Redux. This is what Redux is. That's it. Like, this is it. That's all Redux is. You have a store, holds information, expects signals, a reducer translates those signals into state changes, and then produces a new state. The workshop will be showing you how that makes sense in the React architecture. And in this case, what's going to happen, which I referenced before we started this lecture, is all that stuff in your app container right now. The initial state that's getting set in your app container, and then all those AJAX calls that's saying like this set state. Those are all going to be moved to a Redux store. So albums, artists, songs, current song is playing. That is all going to be in a set of information controlled by Redux. And the only way you're going to get to change those things is if your app container sends actions into the Redux store, saying loaded albums, or set song, set current song, or pause song, or play song. And the idea is that everything that's happening in your app just happens based on that information set, which is now being moved out of React and into a centralized place. It also means that everything that happens in your app goes to the same location. Anything possible that can happen in all of Juke, it's going to go through Redux, and you're going to see a console log for it, which is amazing, If you were learning Angular, there's this idea of factories and views, and essentially you have all of these different connections where you'd have this view, which was being controlled by this information set, this view, which was being controlled by this information set, and then this view, and this view, and this view, which were all being controlled by this information set. And then these information sets can connect to each other. So which means that like this thing, what happens here, could change this thing over here, and you have no monitoring of it whatsoever. As opposed to React now, where we have this big tree of components. And anything that happens to that tree sends an action out to Redux, figures out the new state, and then gets fed back into the tree from the top. So you know that anything that happens in your app goes to this, goes through Redux. That gives you a tremendous amount of predictability. And that's what good programming is all about, is clarity and predictability. That allows for you to solve bugs easier, for you to build faster, so you're not wondering where things are. You have less mystery about where things are happening. So Redux is great, even though it seems either maybe for you confusing or simple or contrived. It's probably one of those three things, but trust me, it's amazing. It's great. Makes you build applications better. It's 6:32. We out. Be safe getting home, everybody. I know. I really appreciate you coming in. I was sort of scared that it would just be like me and Gabe and the other instructors here today. We would just be like talking to empty chairs. So I really appreciate you being here. And yeah, that's it. Good night, everybody. Bye, internet people. See ya. No thank you for you coming in, but it's understandable. Hey.